All right, we're back again today. We're speaking with Dr. Katia Fernandes from the University of Arkansas up in Fayetteville, and so thank you for joining us.
Thank you for having me. It's a pleasure.
You bet. So tell me a little bit about yourself. You know, I think it's kind of interesting. You're a climate scientist, and you're at U of A. So how did we kind of get here?
Yes, I'm originally from Brazil, from a state that in Brazil represents similar things like Arkansas. Is a rural state, is the Brazil's largest rice producer. So I'm originally from a rural state. And in there I studied meteorology. I went to grad school for meteorology and atmospheric sciences. I had my PhD in Georgia Tech in Atlanta. From there, I went to work on research, applied research. And it was interesting in the sense that it was a period in which I really came to appreciate how you use climate science for the benefit of society. And from there, I came to University of Arkansas in 2019 to the Department of Geosciences, and I've been there since, very happily teaching and doing research.
Yeah, absolutely. So what kind of research are you doing right now?
Right. My background is mainly climate science, tropical climate science, and how we can use climate information for instance, for managing and predicting fires in the Amazon biome. So that is my main focus of research. I also conduct research on climate science and some aspects of agriculture use. And more recently, I've been toying with the idea of looking at fire dynamics here in our region. It's something new for me, and I'm getting more interested on it.
So, yeah, what parallels have you seen kind of between your research in the past and how has that been applicable here in Arkansas? I mean, have you?
My background looking at climate and fires is very different from what we see here. For instance, in the Amazon, fires are not natural to the system. We have fires because we have human activity. But around here, some of the fires are more natural. You can get forest fires that are typical of the ecosystem. You have crop burning, and I would like to understand a little better how climate can influence these different type of fires. If a certain level of drought, would that impact crop burning? Would there be information that I can provide that would be useful to farmers to manage fire better? Right. So this is the kind of questions that I'm interested in pursuing. And of course, that only works if I manage to get feedback from farmers.
Right.
Because we are trained academically, but the use of information, we really only get a grasp when we talk to people, and hopefully I'll get to do that.
Right, absolutely. And I mean, that's kind of the journey that we're having on our podcast. As you know, this was funded by our Department of Agriculture, and we're definitely making efforts to get the story and to hear the year specifically from the mouths of farmers. And right. So, thanks for joining us. And so I think this summer has been kind of unique, climate-wise, farming-wise, and now even fire-wise. You know, as of late July, our entire state is under drought conditions from the National Weather Service, with 90% of the state being registered as a D1, and then at least a quarter of the state under a D2, and that was probably a couple of weeks ago when I got those numbers, so it may be even worse now. And I know northwest Arkansas, up there around Fayetteville where you're at, that's about the worst of it as far as the drought conditions. So, I mean, what do these kind of classes, these D1s and D2s, what does that entail? How do we come to those numbers?
Right. So this is based on research, and there are some indicators that are looked at to come up with indices. One of them is precipitation, the other one is soil moisture, stream flow, river stream flow is important, and those indicators combined, they compose the indices. They can go from D0 to D4. D0 is abnormally dry, mild drought, and D4 is exceptionally dry. We didn't get to that level, fortunately. But in the northern part of Arkansas, we had D3, and that is extreme drought. And for these different levels of drought, you have different impacts. From mild drought, for instance, in Arkansas, you might start seeing already increased fire risk. D2s, severe drought, you start seeing already some burn bans implemented. D3, you start seeing already pastures being depleted, changes in river level and water table. Trees start to show signs of stress. So for each level, you have some of the impacts that you usually see with that level of drought, and that alert farmers on what to expect.
Yeah, so I mean, I think it's interesting because all 6 of our stories, our farmers are talking about. We've got hay farmers in central Arkansas, and they're, it's the crop's not coming in, and then on the other side of the coin, we have cattle farmers all over the state that are already having to put out hay much earlier than we're used to. So everything is happening faster and more expensively than we anticipate normally in a year. The other thing we've seen, like maybe as a cause of the dryness or as a reaction to the dryness, I live in Little Rock, and we saw the other day that we went 14 days straight hitting the triple digits. Which I feel like, to me, I feel like we say this every summer of, man, I can't remember the last time it was this hot. But that's got to be abnormal for Arkansas, right?
It is. 2022 has been very anomalous. And in the northern part of the state, and when we had up to July 26, we have these high levels of drought. It might have improved a little bit from the precipitation that we had at the end of the month. But we are likely to see August similar to that. And in terms of the heat, it was unusual. There are some, I collected some statistics, for instance, in Lead Hill, which is in the northern central part of the state. They also had 14 days of temperature above 100 degrees Fahrenheit. Mm-hmm. And that happened only twice in July since 1950. Mm-hmm. In Marshall, which is also in the northern central part of the state, they did not have a temperature above 100 degrees since 2012 in July. So it is pretty unusual, pretty extreme. And what was common to all of these places for most of the state, that this heat was paired with deficient precipitation. Some locations by July 26 didn't have not even 1/3 of the normal precipitation you should expect for July.
So much of what we talk about is kind of cause and effect, and how several different factors kind of come together to create a major problem. And, we've talked about the heat, we've talked about the dryness, and we've talked about fires. And, right now 56 of our 75 counties have burn bans on, where, you're not allowed to light a fire, on your property for fear of it spreading and getting out of control. I live in North Little Rock, and city ordinance says fireworks are against the law, but of course July 4th comes, people shoot off. I have a bamboo thicket in my backyard that has gotten extremely dry this year, and it caught on fire because of a rogue firework this year, which is something, this is our 3rd summer at the house, and I've never seen anything like that. We had to have the fire department come out and spray it down. So this idea of burn bans, this is something I've grown up with. I've always been in Arkansas. Of course, at some point during the summer, we always have burn bans put on. What's kind of like those drought settings, what's kind of the mentality behind these burn bans? When do we kind of check that box and say things are bad enough?
I'm not completely familiar with all the rules that go into burn bans, but I understand that from the physical climate aspect of it is when we reach a certain level of drought, precipitation under a certain level, And for example, the D2 severe drought is when you start seeing effects on trees. Trees start to show signs of water stress, and then I believe that's when the burn bans are implemented.
You know, it's so interesting because here we find ourselves, and you read the scripts from our farmers this month of, they're just kind of standing there watching, going, just praying for rain and irrigating when they can. Whereas 2 months ago in the spring, I mean, we had row crop farmers that couldn't get stuff in the ground because of how soggy things were. Is there a weather phenomenon? I hear phrases like it's a La Nina season or an El Nino season. Is there something to kind of explain that really wet spring and now we're in a drought?
So the wet spring and the drought are separate events. Okay. But in the spring, we do have a La Nina. It's going on the third year strong. And a La Nina phenomenon is described by very cool waters on the ocean, the Pacific Ocean, off the coast of South America, in the tropics, and warm waters in Indonesia. That's what describes a La Nina. El Nino is the opposite. Warm waters off the coast of South America and cooler waters near Indonesia. And it seems way far from us, but those anomalies in ocean water temperature, they change atmospheric patterns, winds. So, for example, during a La Nina spring, we have the jet stream, which is a band of very strong winds aloft, and those winds, they help steer cold fronts, for example, over our region or away from us. And during spring, in La Nina years, we get the jet stream in a way that we get a lot of storms. And we saw that. We saw EF3 tornado in Springdale in March this year. It was ugly. We got a hailstorm in April. And with that, we get a lot of precipitation. So there is background climate signal to these strong storms during spring. Now in summer, what we are seeing or what we saw for most of July was what we call a heat dome. In a heat dome, there are two things to it. One is very humid and warm air that is developing because of rising temperatures, rising ocean temperatures, that warms the air above it. And that warm and hot air is transported towards us in the U.S. And if it finds atmospheric conditions like a high-pressure system is a system that simply explain very stable atmospheric conditions. So you have hot and humid air coming towards us, gets trapped, and it stays put for days or weeks. So that's what we have. And under those conditions, the storms go around us, go to the north of us, to the east of us, but we, being at the center of it, very stable weather prevails, and we get dry and hot for weeks.
So a lot of your research, I mean, you research the climate change, but you've also worked very closely to agriculture in your research. And so have you seen anything used in other areas? Do you have any advice for Arkansas farmers kind of under this situation, which now, I mean, you've kind of spoke to it already, is that we're seeing some rain here at the end of July. And so maybe we're going to get a little relief, but me being a lifetime Arkansan knows August and September are going to be pretty bad as well. They should be hot and dry. And so what are your thoughts on kind of surviving the season?
Right. As a climate scientist, my suggestion is try to make the best use you can of climate information. The U.S. is fortunate in the sense that it has had records of data, meteorological data for centuries, and that helps a lot us understand climate better. So try to perhaps rely on that information as much as you can. And for this next season, August And then September, October, November, the NOAA is releasing their outlook, and it looks like August is going to still be hot and dry. But there is some positive news that at least we might see improvement in drought conditions. It's still dry and hot, but not as much. And September, October, November, also there is high probability of hotter than normal and drier than normal, especially northern parts of Arkansas. Okay. But that's what I would suggest. And also, sometimes farmers know way more about climate for their use than we academics do. And sometimes I think that it would be worth reaching out to a climate scientist and asking, can I get this type of information? Is that something you can help me obtain? Mm-hmm. And I always give an example that we find easily seasonal forecast for precipitation anomalies. But sometimes a farmer might say, I actually need to know if that precipitation is going to be concentrated in a few days or well distributed over a season. Can I get that kind of information? And sometimes it requires some research, right, but it can be done. Right. So I think it's there is room for collaborative work among us.
No, yeah. I mean, I think, again, you're kind of echoing how our podcast got started of we see this problem with farmers. You know, we see that they're kind of struggling with a set of issues. And so on our side, it's the mental health thing, but on your side, it's the climate thing. And you kind of want to say the experts are here. You know, I mean, the experts are in Arkansas, and we're happy to talk to you about how to solve these problems. So that's a great idea. You know, we've talked a lot about climate and something that comes up a lot in our conversations and something that's kind of become, you know, across America right now is that climate and weather are two different things.
Right.
So kind of give me a quick definition of maybe the difference between climate and weather.
Right. So weather is what you're going to get in the next few days. It's a matter of time scale. So weather is forecast for the next few days, and we have very good models that do a good job in forecasting that. Climate is the general behavior of the weather over a longer time period. It could be a season, it could be years, it could be decades, centuries. It really depends. So climate is more the background signal, and the weather is what happens on top of that on the scale of days to perhaps 2 weeks.
Right. Okay. And so what I think is kind of interesting or maybe alarming at this point, you know, I mean, we're talking to farmers right now about this drought, and a lot of folks are saying, well, it's not as bad, or it is as bad as the 1980 drought, right? I mean, we kind of hear echoes of when was the last time we saw kind of this freak incident occur and hit us hard. But even at the beginning, you know, when we were talking about the rainy season back in March, we spoke about the Arkansas River flood. That was, 3 years ago now, I think, or 2.5. And so I kind of got to thinking when you and I were speaking about climate, we've seen a river flood that's kind of a 100-year event.
Right.
And then in February of 2019, I believe, we saw a snowstorm that was kind of a 100-year event for Arkansas. And now we find ourselves in a drought that is at least a 50-year event, and it may prove worse by the end of September. Are these related? You know, I mean, I feel like we're kind of seeing these anomalies very often.
Right. So each individual event is triggered by different atmospheric conditions in the examples you gave. What they do have in common is they are happening in a more extreme way. And that happens in a warmer environment. So if we can think, for instance, in drought conditions, you can think of the atmosphere as a sponge. You will take water from the surface, and liquid water will evaporate and be stored in the atmosphere. So we all know that. In a warmer atmosphere, we have a bigger sponge. So more water vapor can be held by the atmosphere. And that's not bad at face value. Water is there. Except that for farmers, for example, they need liquid water for their use. So water that is evaporated is not ready for use. And again, in a warmer environment, more of that liquid water goes into the air, and we get more extreme drought conditions. So that's one. So you can think of that atmosphere, warmer atmosphere with more water vapor in it. At some point, that water vapor will become droplets and form clouds and precipitate. And if you have more water vapor in it, you are going to have more precipitation. And when water vapor condensates and becomes a droplet, it releases heat. So storms are more energetic when you have more water vapor in it. So when it rains, it pours. So the same process of a warmer environment can lead to more droughts or more rainfall, more snowstorms. That water vapor will come down either in the form of water or snow. So it's not really surprising that we are seeing more of these extremes. And one last thing I would say is that you might think, well, the water is going up to the atmosphere and it's coming back, so it's fine. Except that evaporation can happen in a place where you have drought, be transferred someplace else, and rain where water is not needed. So these extremes become relevant for producers because, again, everything is more, and I like to joke, is on asteroids.
Right.
Everything is more extreme.
Right. Yeah, absolutely. So it's almost like a pendulum, and so it's just swinging further and further. So we end up with snowstorms in the winter, and then we end up with heavy droughts in the summer.
Yeah.
Okay. Yeah, I never realized. Again, it's kind of that enlightening thing of we're working with farmers, and each week we talk about money, or we talk about weather, or we talk about the economy, and you kind of begin to realize how interconnected everything is. And now we're talking about weather and climate patterns for over 3 years, and you're like, oh, those are kind of causing and answering each other, which is very interesting.
Best of luck to all the farmers, climate-wise.
You bet. Well, we appreciate it, and thank you so much for joining us. And